So, picture this. Out in the deep, vast quiet of space, something that should have been completely silent suddenly, and I mean suddenly, roared to life. We're talking about a tiny, lonely object that just threw a tantrum of cosmic proportions, and what it did might just force us to rewrite the rules for how worlds are even born.
And that right there, that's the big question we're going to dig into. You and I, we're used to thinking of planets as, pretty calm places orbiting a star. But what happens when you have a planet with no star at all, and it just decides to start acting like one? Well, the answer turns out to be absolutely spectacular.
So let's meet the main character in this whole cosmic drama. It's something called a free-floating planetary-mass object, or FFPMO for short. Just think of it as a ghost planet, which is a pretty cool name, right? It has the mass of a huge planet like Jupiter, but it's not tied to any solar system. It's basically a young cosmic nomad, just wandering through the galaxy all by itself.
Okay, so the specific object we're focusing on has a name. It's a bit of a mouthful. Cha J1107077626. Now, I have to stress, on a cosmic scale, this thing is tiny. We're talking only about 5 to 10 times the mass of Jupiter. For a long, long time, it was just another faint, quiet little blip in the sky.
And this right here is where our story gets really, really interesting. You've got astronomers using these incredibly powerful telescopes, pointing them at this quiet little object, probably expecting business as usual. And then, out of nowhere, it woke up.
And just look at how fast this all went down. For the first part of 2025, everything's normal. The object is in what scientists call its quiescent state. That's just a fancy word for chillin'. Then, in June, bam! Telescopes pick up this massive flare-up, and this wasn't just a quick flash in the pan. By August, it was still going strong, a cosmic storm that raged for months.
So, you're probably wondering, how big of a deal was this flare-up, really? Well, in visible light, the object suddenly got more than 6 times brighter. It's like, imagine you look up at Jupiter tonight and it's its normal self. Then tomorrow night, it's blazing 6 times brighter. You'd know something truly weird was going on. And that's exactly what happened here.
So now, scientists have this massive cosmic mystery on their hands. They had to become cosmic detectives, really. Because all that light streaming from this outburst, it was carrying a unique set of fingerprints. And if they could just analyze that light properly, they could figure out exactly what was happening hundreds of light years away.
And the number one clue, the biggest lead in the whole case, all pointed to this one process called accretion. Basically, this little object is surrounded by a huge disk of gas and dust, and the burst happened because it suddenly started feeding on that disk. Like, a lot. It was a full-on cosmic feeding frenzy.
And when I say a lot, I mean the change was just insane. Before this whole thing, it was just kind of nibbling at its disk, a low and steady rate. But during the burst, that feeding rate went through the roof. We're talking 6 to 8 times higher. This thing went from snacking to an all-you-can-eat cosmic buffet.
I mean, just look at the difference here. The transformation was total. It went from dim to dazzling. Its feeding rate exploded. Even its light signature, its fingerprint, got way more complex. And get this, scientists started detecting water vapor where there was absolutely none before. That's a huge sign that something truly dramatic was going on.
But out of all these incredible clues, there was one piece of evidence that stood above the rest. It was the real aha moment, the smoking gun. A very specific, unique pattern hidden in the light that basically spelled out not just what was happening, but exactly how it was happening.
And here it is. Now this is a little technical, but hang with me. A specific kind of light called the H-alpha line developed this strange, double-peaked profile. Now to you and me, that might not mean a whole lot, but to an astronomer, that is a giant, flashing neon sign. It screams funneled accretion, a process we normally only see happening with young stars.
So, what in the world is funneled accretion? It's actually pretty cool. Think of it in 3 steps. First, the object's magnetic field reaches out and grabs onto the gas and dust in that disk. Second, that material gets channeled along magnetic field lines like a giant funnel in space, forming powerful streams. And third, those streams slam onto the object's surface, creating these insanely hot spots that glow like crazy. That's the flare-up.
So, what's the verdict here? All the evidence, the incredible intensity, how long it lasted, that smoking gun light signature, it all pointed to one unavoidable conclusion.
This was a very specific kind of cosmic storm, the kind that had never ever been seen on something as small as a planet.
Yeah, this storm actually has a name. It's called an EXor-type burst. And let me tell you, these are the big ones. They're not your everyday solar flares. They're long, powerful, violent outbursts, driven by that intense feeding frenzy. And the thing is, until right now, we thought only young stars could pull off something this dramatic.
So what does this all mean? It means that Cha J1107077626 is the first planetary mass object ever in the history of astronomy to be caught having a full-blown, star-sized EXor burst. This is a cosmic record breaker. We've got a ghost planet that is acting just like a baby star. And this number right here, this is what cements its place in the history books. That's its peak feeding rate, and it is just mind-bogglingly high for an object this small. This is, officially, the highest mass accretion rate ever measured for a planetary mass object. Period.
Okay, so a tiny object had a big outburst. So what? Why does this matter to you and me? Well, it matters because this small, lonely planet throwing a star-sized tantrum completely challenges what we thought we knew. It fundamentally blurs that neat little line we've drawn between what makes a planet and what makes a star.
Seriously, this discovery is a total game changer. It shows that the way stars and planets form might be a lot more similar than we ever thought. It proves that even these little guys can grow through these violent, chaotic bursts, just like their bigger stellar cousins. And what's more, some older data hints that this might not have been a one-time thing. These storms could be happening again and again.
So, getting to watch one of these ghost planets go through a cosmic growth spurt like this in real time, well, it's more than just a spectacular light show. It's a massive clue that helps us solve one of the biggest debates about what these mysterious objects really are.
See, the big question has always been this. Are these things failed stars, the runts of the litter that just never got big enough to ignite? Or are they giant planets that formed in a normal solar system and then got violently kicked out? Well, seeing this one act exactly like a baby star, feeding from a disk, having huge outbursts, that's a huge point for Team Failed Star. It suggests they're born small and they grow up in the exact same way stars do.
And that leaves us with one final, tantalizing thought, doesn't it? We thought Cha J11077626 was quiet, maybe even a little boring, until it really, really wasn't. So it makes you wonder, how many other ghost planets are out there, wandering through the darkness, hiding their own incredible cosmic storms, just waiting for us to look at them at the right time?